My dear students, I welcome you with a bang. Okay, I welcome you all for the next lecture, and we have to continue with exercise 5.3, that is arithmetic progression, and we have completed till sorry my dear students. So we have completed till question number 5. Now we will go to question number 6. Let us see how much we are able to do today. Now I hope you all have got your textbooks ready. Reading the question number 6. The first and the last term of arithmetic progression are 17 and 350. So this is the first term. That means this is A1. And this is the last term. You can call this as L or AN, whatever it is. If the common difference is 9, then this is D. How many terms are there? How many terms are there? Means what are they going to ask? N. And what is their sum? The Sn. Whatever is this N is, we have to find this also. Okay. So let's proceed. Here I start solving the question. Question number 6. The first and the last term. The A1 is equal to 17. Last term is equal to 350. Common difference D is equal to 9. These all things are given. To find, what do you have to find? N. And you have to find Sn. That's all. Okay. So we are very sure that actually Sn ka formula, no, Sn, because okay, for this L is equal to An we have to take. Let L be equal to An is equal to 300. Because actually if you go to use this formula, Sn is equal to C n upon 2a plus n minus 1 into D, or you use another formula, Sn is equal to n upon 2 a plus L. See, here you don't know this, and again you don't know n. These two you know, but two terms you are not knowing. This is not going to help you. You should know all the terms except one. Only one term you should not know, S and n, and you are not using this at all. So what we have to do is, we have to use L is equal to An, and then we have to use this formula. We know that for an arithmetic progression, Tn is equal to A plus Tn or An, sorry. This An is equal to 350 is equal to A is 17. N we don't know, and D we know 9. For An is equal to 350. This is what we are using. Okay. So now what do we get over here? 17 goes on the other side. 333 is that? Yes. Now this 9 also comes over here, n minus 1. This should divide this. If you consider 3 3s are 9, 3 1s are 3, 3 1s are 3, 3 1s are 3. Again 3 3s are 9, 7s are. So you get 37 is equal to n minus 1. Therefore n is equal to 37 plus 1. N is equal to 38. So you get that the number of terms involved over here are 38. Now we have to find Sn. Now Sn we can find in any way. This also we can use. We know that for an arithmetic progression, Sn is equal to n upon A plus L. Now Sn we have to find. N is 38 upon 2. A is the first term, 17, and L is the last term, 350. This will definitely divide. So Sn is equal to 19 into, if I add this 7, 6, 367. So 367 multiplied by 9 7 63. 54 plus 6, 27, 28, 29, 30, 31, 32, 33. Okay. 3, 6, 7. This gives you 3, 7, 9, 6, 9, 7, 3 should be the answer of this. I forgot to take the solution today also. We still. That is going to be a problem. Actually, things are always right, but can't take a chance. It is right, my dear students. This is right. Okay, so with this we proceed for question number 7. Okay, so we go for question number 7. Now in question number 7, find the sum of first 22 terms. Sum of first 22 terms means now we have to find S22 of an arithmetic progression which D is equal to 7, and 22nd term means T 22nd is equal to 149. This is given to you. And you have to find this. D is also given. So what all things are given? T 22nd is given, means A 22nd, sorry. A 22nd is equal to 149. This is given. And D is equal to 7 is given. Of course, then A 22nd is 149, and they have asked you S 22nd. S22. That means n is equal to 22. Here also A22 is given to you. There is nothing. Only first term you will require. See, you will require to find first term anyhow, because even if you use S n ka formula means S22 is equal to n upon 2 A plus n minus 1 into D. In this formula, n you know, D you know, but A you have to know, na? Because Sn you have to calculate. Two things are not known. If you use this formula, A plus L, here also 22nd term L you know, N you know, but A you will have to calculate. So we will calculate A with the help of this. We know that for an arithmetic progression, An is equal to A plus n minus 1 into D. Now we are using it for A22. A22 is equal to A plus 22 minus 1, 21D, for n is equal to 22. So A22 we know it is 149. A we have to calculate, plus 21 into D will be 21 into 7. This is substitution. So what do you get over here? 149 minus 7 to the 7, 7 to the 14 is equal to A. 2 is equal to A, therefore A is equal to 2. Okay, got that A is equal to 2. Now you can use any of these formulas. Sn is equal to n upon 2 A plus n. Sn is what? You have to calculate S22 is equal to 22 upon 2. A is 2 plus L is, means A22 we are taking 149. Since L is equal to A22 which is equal to 149, they both are going to be same. So I get S22 is equal to 11 into 49, 50, 51. 11 with 11, 55, 56, 561. Therefore, sum of 22, first 22 terms is here I did a mistake. 11 with 11, 149 plus 2 will be 151, 55. This should be 1661. 149 plus 2, 140, 149, 150, 151. This is 1. 161 is the right answer. Okay, my dear students, so let's go forward. Question number 8. Find the sum of first 51 terms. So again, they are asking us to find S51 terms. Means to find S51, whose second term and third terms means A2 is equal to 14, A3 is equal to 18. These are the second respectively. So again, if you see, if they are asking you to find S51, see, whenever they are asking you to find S51 or S terms, you should always first see the equation of S51. Solution, if I carry, we know that for an arithmetic progression, Sn is equal to n upon 2 into 2a plus n minus 1 into d. This is what you know. Now you have to find S51. Therefore S51 is equal to 51 upon 2 into 2a plus 50d. 2 comes out, a plus 25d. So what do we get is S51 is equal to 51 into a plus 25d. So even if we get the value of a plus 25d directly, we can still get S51, and that is what we have to find, only S51. Okay, so this is what we will keep in mind. And now we will frame the simultaneous equation of A2, we will frame the simultaneous equation of A3 and solve it. Okay, so we know for an arithmetic progression, an is equal to a plus n minus 1 into d. Therefore, a2 is equal to a plus 2 minus 1, 2d. But a2 is equal to 14. Therefore, a plus 2d is equal to 14. This is going to be a second equation. Now, a3 is equal to a plus 3 minus 1, 2d. But a3 is equal to 18. Therefore, a plus 2d is equal to 18. This is going to be a third equation. Now, just give it a try. दोनों 2d कैसे आएगा? a plus d, this is 2 minus 1, sorry, a plus d. A2 is equal to a plus 2 minus 1, 1d. A3 is equal to a plus 3 minus 1, 2d. This is a plus d is equal to 14. This is a plus 2d is equal to this. So if I go to solve this, I am not going to get, even if I add these two, I will get 2a plus 3d. Here I require a plus 25d. So there is no other go. I will just have to find a and d separately. Subtracting equation 3 from 2. We get a plus d is equal to 14 and a plus 2d is equal to 18. This is gone. Minus 2 is equal to minus 4. Therefore, d is equal to 4. You will get d is equal to 4. Now substituting, one. You get a is equal to 14 minus 4, a is equal to 10. So this A and this D you substitute over here, still you will get S51. Okay. So what is the value of V from 1? S51 is equal to what? 51 into A plus 25D. 51 into A plus 25D in bracket. This is what it is. S51 will be equal to 51 into what is A? 10 and D is 4. 10 plus 25 and D is 4. What do you get over here? S51 is equal to 51 into 10 plus 425 is 100. S51 is equal to 51 into 110. Now this if I multiply 5610. Okay, this should be 5610. This is right. Therefore, sum of first 51 terms is 5610. This is done. So we have done with question number 8. Now we proceed to question number 9. If we go to question number 9, if in this question number 9 what they have done, if the sum of first 7 terms of an arithmetic progression is 49, that means they are telling S7 is equal to 49. This is given. And that of 17 terms is 289, means S17. Find the sum of first n terms. See, find the sum of first n terms means actually again we have to find Sn. Sn. And when we have to find Sn, you just have to, what you just have to do is that in the formula of Sn, n upon 2, 2a plus n minus 1 into d, you have to substitute the value of a and d. Substitute the values of a and d of the arithmetic progression and you will get the, solve this, simplify this, you will get the general sum. Remember general sum. I have told you my dear students, this is the formula for general sum. We know general term is equal to a plus n minus 1 into d. We know Sn is equal to n upon 2 into a plus n. And we know Sn is equal to this. These are the formulas which are actually applicable to all the arithmetic progressions that you are dealing with. All the arithmetic progressions are going to follow these formulas. But every arithmetic progression has a formula of general sum, general term of its own also, which is dedicatedly applicable on that one arithmetic progression. And to get that formula, what you have to do is that you have to substitute the value of A and value of D of that arithmetic progression in this universal formulas. So in this also, this is one arithmetic progression in which sum of 7 terms is 49, sum of 17 terms is 289, and you have to find the formula of Sn, which is dedicatedly applicable on this arithmetic progression. Simple it is. What we have to do is that we have to first solve this and get the values of a and d using simultaneous equations. Okay, and those a and d we have to substitute in this formula. No, this Sn. Okay, then we get what? What they have asked? Find the sum of first n terms. Find Sn. So we will do the same thing again. We know that for an arithmetic progression, Sn is equal to n upon 2, 2a plus n minus 1 to d. So S7 is equal to 7 upon 2 into 2a plus 7 minus 1, 6d. But S7 is equal to 49. Therefore, 49 is equal to 7 upon 2, 2a plus 6d. Here 2 can come out factor, common factor. Okay, so 49 is equal to 7 upon 2 into 2a plus 3d. Fine. Now this 2 has gone. Now you have to be careful. 49 upon 7 is equal to a plus 3d. 7 gone. Therefore a plus 3d is equal to 7. This is your first simultaneous equation. Similarly, you use for S17. 17 upon 2. 2a plus n minus 1. But 289. Therefore, you will get 289 is equal to 17 upon 2 into 2a plus 17 minus 1, 16d. Again, I will do the same thing. 289 is equal to 17 upon 2 into 2a plus 8d. This is gone. 17. So you get a plus 8d is equal to 17, and this becomes your second equation. So now two simultaneous equations you have got. Solve these two simultaneous equations and you will get the value of a and d. Those the values of a and d, you have to substitute the universal formula of Sn. Simple. So a plus 3d is equal to 7, a plus 8d is equal to 17. Subtraction minus, this is gone. Minus 5d is equal to minus 10. Therefore, d is equal to minus 10 upon minus 5, d is equal to 2. This is done, my dear student. So d, we have got the value of d, and now substitute this d is equal to 2. In equation 1. That equation 1 is a plus 3d is equal to 7, a plus 3 into 2 is equal to 7, a plus 6 is equal to 7, a is equal to 7 minus 6, a is equal to 1. These values you have got. So now you will tell, we know for arithmetic progression Sn is equal to, this is the universal formula. In this universal formula, I will substitute the values of a and d. Okay, a and d I will substitute. What I get, Sn is equal to n upon 2. 2 ones are 2 plus this again 2n minus 2, and this 2 is multiplying both the way. 2 से 2 मर गया. What do we get? Sn is equal to n upon 2 into 2n. Here also 2 is gone. Sn is equal to n square. This is the universal. This is the formula of general sum, which is applicable only on this arithmetic progression. Okay, so this way we have got. We are finished with question number 9. Now we can think about question number 10. Okay. Question number 10. Show that A1, A2, An form an arithmetic progression where An is defined as below. Okay. See, it is a simple question. Okay. See here, show that A1, A2, An form an arithmetic progression where An is defined as, see, this is the first question, first sub question. An is equal to 3 plus 4n. Now this is a general formula for general sum, general term. This is the formula for general term. And this formula for general term is dedicatedly for one arithmetic progression which we don't know at present. We have to form the arithmetic progression as they have told. This An is equal to this. So we have to find A1, we have to find A2, we have to find up to An. Okay, and then we have to show that this is a arithmetic progression formed. So here what we will tell, for n is equal to 1, A1 is equal to what? 3 plus 4 into 1, that is equal to 3 plus 4, that is equal to 7. This is your A1. Now usually we know D, so we could have taken A1 plus D, but we don't know D, but we know formula for general term. So we know a better one. So this will be A2. For A2 we will take 3 plus 4 into 2. That will be 3 plus 4 to the 8, 9, 10, 11. Again A3 is equal to 3 plus 4 into 3. That will be 3 plus 4, 3 that 12. That is equal to 15. Okay. A1, A2, A3. A3 was also not required. They have told us to frame it up to A1, A2 and AN, actually speaking. This is 3 plus 4n. Actually we can try to make it slightly complicated but not needed. Therefore the arithmetic progression is 7, 11, 15 and so on. Where D is equal to what? A2 minus A1. They have told us to show that this is an arithmetic progression. To show that this is an arithmetic progression, therefore the sequence, we have to prove that this is an arithmetic progression. A2 minus A1 is equal to 11 minus 7. This will be 12, this is 8, 9, 10, 11, 4. Then D is equal to A3 minus A2, which is again equal to 15 minus 11, which is still equal to 4. We could have taken one more. A4 is equal to 3 plus 4 into 4, 3 plus 16, 19. So D is equal to A4 minus A3. A4 is 19 minus 4, still equal to 4. Since A raised to the power of n minus A raised to the power of n minus 1 is equal to 4 is constant. Therefore the common difference is constant. Therefore the given sequence is in arithmetic progression. Simple. Okay. Similarly, we will do for the second question. You can try doing it and pause the video, try doing it, and if you have any problem you can see it again. Here we have told that an is equal to 9 minus 5n. For the a1 is equal to a minus 5 into 1. 9 minus 5 into 9 minus 5, that will go to 4. A1 is equal to 9 A2 5 into, that will be equal to 9 minus 10 minus 1. Fine. A3 will be equal to 9 minus 5 into 3, 9 minus 15 minus 6. A4 is equal to 9 minus 5 into 4, 9 minus, that will give you minus 11. Okay. Therefore the sequence obtained is 4 comma minus 1 comma minus 6 comma minus 11 comma in this question, where D is equal to A2 minus A1. A2 is minus 1 minus 4, that is equal to minus 5. So D is equal to A3 minus A2. A3 is minus 6 minus 1 plus 1, still minus 5. A4 minus A3. A4 is minus 11 minus 6, that means plus 6 minus 1. Since the common difference D is equal to minus 5 is constant, therefore the given sequence is in arithmetic progression. Simple. Okay. Now 11th one, should we go for or not? If the sum of first n terms of arithmetic progression is 4n minus n square, what is the first term? That is S1. Okay. What is the sum of the first two terms? What is the second term? Similarly, find third, 10th, and see here one new thing now you are going to learn, my dear friend. This is slightly new, very new, and very, very important. See, we know that from, you have seen now, just now you have seen that from an, when you know an, you can easily frame an arithmetic progression. You just have to, in the place of n, you have to go on substituting the values of 1, 2, 3, 4, and you will get first term, second term, third term, fourth term, and then sequence is getting generated. This is when an is given. You have seen two examples. Just now you saw two examples. Here also an is given. In this an, you go on substituting the values of 1, 2, 3, 4, and you will get a1, a2, a3, a4, and that means you are getting a sequence. What if supposing instead of that, instead of giving an, if Sn is given, then what happens? Like Sn is given, whatever it is, n upon 2 into a plus n minus 1 into d. Then what happens? Can I frame the arithmetic progression even now? Yes, you can, my dear student. What is the logic behind it? See, try to understand. When you have to frame arithmetic progression over here, first of all, a1 will be equal to s1, straight. Whatever is this equation, in that you substitute 1, that will be s1. Because if you have any, see, s1 will be what? a1. S2 will be first term plus second term, right? But S1 will be A1. Na? So S1 and A1 are always same. So A1 you will get. But to get A2, what you have to do, you know, A2 will be always equal to S2 minus S1. Whatever is this A2 to S2, I have to find S2 and I have to find S1 and subtract the two, S2 minus S1. Similarly, if I have to find A3, it will be equal to this 3 third, no? S3 minus previous one, S2, will give me A3, third term. If I have to find A10, then what I will find? S10 minus S9, immediately the previous term. This is what you have to follow. If I have to find A21, to find A21, 21st term, I will have to find S21, means substitute 21 in the place of N, AD, and get S21. And then I will also have to find S20, one step behind, one number behind, and again I have to find, in this same formula I have to substitute 20 also, N is equal to 20, and solve that. And the 2 when I subtract, then I will get A21. That means, very carefully now understand, an, any nth term, what I will have to do, find Sn, and I have to find one n behind, Sn minus 1, one n behind, and then subtract the 2. Then I will get an. This is very important, my dear students. You can write it down, take a pic of this. This and not a pic, you could actually, important explanation this is, you can mark it, bookmark it, whatever it is, this video you can actually bookmark it. This is a very important logic and very important concept. If any tricky question is supposed to be asked, they always prefer, they can try to trick you somewhere over here. Because lots of questions are not, there are not many questions on this topic. You have to understand this, A1 is always equal to S1, and then A2 is equal to S2 minus S1. Even if they ask you A99, then what you will find? S99 you will find first, using n is equal to 99 in this formula. Find S99 minus 1 n behind, S98. When you will subtract the two values, you will get a value over here, you will get a value over here, two values, then you will get A99. Remember this. Now we will see in this given question, you will understand. Here they have told, if the sum of the first n terms is 4n minus n square, means see here, they have given you the dedicated general sum formula. Usually it is Sn is equal to n upon 2 into 2a plus n minus 1 into d. But they have given a formula of that arithmetic progression is 4n minus n square. You can even take it as Sn is equal to, I will take n as a common factor, 4 minus n if you want, otherwise you can leave it like that only. This is Sn. Okay, if you want you can leave it like that only. Okay, I don't want to confuse you. Chalo, forget. Now what they are telling, what is the first term? That is S1. What is the first term? Now remember, first term when they ask you, S1 is equal to 4 into 1 minus 1 square. That is equal to 4 ones are 4 minus 1, that is equal to 3. A1 is equal to S1 is equal to 3. This is your first. Simple. Are you getting? Now they are telling what is the sum of the first two terms. So this is over. Now sum of first two terms means you have to calculate. See, in the first case they asked you to find A1. Sum of first two terms means S2 you will calculate. So S2 is equal to, in place of this formula itself, I have to substitute 2 minus 2 square. So that will give me S2 is equal to 4 to the 8 minus 4. S2 is equal to 8 minus 4, 4. This is sum of two terms. What is the second term? Now they are asking me to find A2. Now remember, A2 will be what? S2 minus S1. But you have already found S2 and S1. You have already got. So you can directly tell S2 is equal to 4 minus S1 is equal to 3. That is 4 minus 3, 1. That will be A2. A2 is equal to 1. Okay? See, now you can understand the arithmetic progression is what? A1 is equal to 3. A2 is equal to 1. So sum of first two terms is 3 plus 1, 4. Right? Okay. Now proceed further. Similarly, find the third and 10th and nth terms. Third term, 10th term and nth term. They are asking you to find third term, 10th term and nth term also. Simple, my dear student. A3 if you have to find, that means A3 will be equal to what? S3 minus S2. Out of that S2 you have got. You only have to find now S3. So S3 is equal to, in this formula I will substitute n is equal to 3. 4 into 3 minus 3 square. 12 minus 9, 9, 10, 11, 12, that is 3. This is S3. Fine. S3 is equal to 3. So now A3 will be equal to what? A3 will be equal to S3 minus S2. S3 is 3 minus S2 is 4. That will be minus 1. Therefore, A3 is equal to minus 1. Don't get scared or don't get bothered. See, it is understanding that it is a decreasing arithmetic progression. 3, 1, minus 1. That's why it is giving some absurd values. Okay? But they are not absurd. They are right. A3 is equal to minus 1. Now A10. Now to get A10, A10 is equal to what? S10 minus S9. So S10 also you don't have. S9 also you don't have. So you will have to calculate both. S10 is equal to, for that you will have to use the formula of Sn. Sn is equal to 4n minus n square. That is 4 into 10 minus 10 square. That will give 4 10s are 40 minus 100. That will be minus 60. S10 also will require and S9 also will require. 4 into 9 minus 9 square. That will give you 4 9s are 36 minus 81. That will give negative 36, 46, 56, 66, 76, 79, 80, 81. That will be minus 43, I suppose. Okay? Fine? No. 46, 56, 66, 76, 77, 78, 79, 80, 81. It is 46. Sorry, my dear student. So this is. फिर भी wrong आ रहा है. क्या कर रहा हूँ मैं? 77, 78, 79, 80, 81, 5, my dear students, sorry. Really very sorry for this, okay? 7, 8, 9, 10, 11, okay, fine. That is minus 45. So this you have understood now, I'm sorry. So now we will come over here to get A10. A10 will be equal to S10 minus S9. That is minus 60. Remember minus 60, minus of this and minus 45, which I usually write directly. Minus 60 plus 45. This will be minus 15. Okay, therefore A10 is equal to minus 15. Like this you have got A10 also. Okay, and now they are asking you to find AN. Now see, AN will be equal to what? Now similarly, we know A3 is equal to S3 minus S2, A10 is equal to S10 minus S9, AN will be what? SN, and I will have to find SN minus 1, one step behind, and then subtract this. Okay, so I will do this in the next page. Sn is equal to what? Sn is equal to 4n minus n square. This is Sn. They have asked me to find An. An is equal to Sn minus S, one step behind, n minus 1. Sn I have got. This is Sn. Sn minus 1. In place of n I will write 4 into n minus 1 minus, in place of n I will write n minus 1 the whole square. Try to understand this. In place of this n I have written n minus 1. In place of this n I have written n minus 1, and square will come as it is, but it will be whole square. So now Sn minus 1 will be 4n minus 4 minus, I am not opening this bracket, I will have to a minus b the whole square, n square minus 2n plus 1. Since a minus b the whole square is equal to a square minus 2ab plus b square. Now I will open that bracket. Sn minus 1 will be equal to 4n minus 4 minus n square plus 2n minus 1. So now if I solve this, I will get Sn minus 1 is equal to n square, I will keep it where it is. 4n plus 2n will be minus n square plus 6n minus 4 minus 1 will be minus 5. This is the value of Sn minus 1. Now An is always equal to Sn minus Sn minus 1. Therefore An will be equal to Sn is what? This 4n minus n square minus, this I will put in bracket again, minus n square plus 6n minus 5. Therefore An is equal to 4n minus n square plus n square minus 6n plus 5. So minus n square plus n square mar gaya. You get An is equal to 4n minus 6n, that will be minus 2n plus 5. That means An is equal to 5 minus 2n. Simple, my dear student. It is really a different one, very interesting one, not at all difficult, but you have to understand it carefully, and then you will be able to solve it. It is not at all difficult, my dear students, but it is really an important one because it is a topic of its own. Okay, so with this we have done something new and something important. Rest, actually speaking, are not that difficult. You can even give it a try for 12th. Find the sum of the first 40 positive integer divided by 6, sum of first 15 multiples of 8. But the video is getting too long. I will do it in the later one. Should I complete it though? Next we will get only 15, 16, 17, 18. It will be a different one. I will do it. Find the sum of first 40 integers divisible by 6. They are very easy, my dear students. We have done this type of questions for AN. So 12th one. Find the sum of first 40 integers divisible by 6. First 40 integers. That means they have, now see, the required sequences. First 40 positive integers. Positive integers means, see, they start with 0, 1, 2, 0, also not 4, 5, 6, up to so on. The first one divisible by 6 is 6 itself, then 12, then 18, and so on. But they want it only up to 40th term. That's all. Okay, only up to 40th term. First, sum of first positive integers divisible by 6. Up to 40th term you have to go. So, since each term constantly increases by 6, therefore the given sequence is in arithmetic progression where common difference D is equal to T2 minus T1, 12 minus 6 is equal to 6. Therefore, we have A is equal to 6, D is equal to 6, and that's all. N is equal to 40. We have to stop at 40th time. They are asking us to find Sn. So Sn is equal to, we can take this formula, A plus, no, we don't know N, no, 2A plus N minus 1 into D. S 40 upon 2 into 2 into 6 plus into D is 6 for N is equal to 40. S 40 is equal to, this will be 20, 2 6 are 12, 40 minus 1 39 into 6. This will give you, I will do, I don't want to complicate it. 6 9s are 54, 6 is 18, 19, 20, 21, 22, 23. This is 234. I get as 40 is equal to 20 into 12 plus this 6, 4, 246. Now this I will multiply 2 6 are 12, 2 4 are 8, 9 2 2 are 4, 9 2 0 is S40. This is the number. Therefore, S40 is equal to 4920. This should be the value. I did not counter check anything. 4920 is right, my dear students. Now we go to the 13th question. Here again, find the sum of first 15 multiples of 8. So here again, multiples of 8 means you have to write a table of 8. This is question number 13. The required sequence is multiples of 8. 8 2s are 16, 8 3s are 24, 8 4s are 32, and so on. They are asking us to write the first sum of first 15 multiples. So here it will come 15th term. That's all. Again everything is same. Since each term constantly increases by 8, therefore the given sequence is in arithmetic progression. D is equal to T2 minus T1 is equal to 16 minus 8 is equal to 8. Therefore, A is equal to 8, D is equal to 8, N is equal to 15. And you have to find the sum. We know that for arithmetic progression, Sn is equal to N upon 2, 2A plus N minus 1 into D. S 15 upon 2, 2 into 8 plus 8 minus 1 into 8. We can do one thing, actually I like to do this because it really reduces. We can take out 8 as a common factor from here itself. If you take 8 as a common factor from here, you will just get 2. Here 2 is remaining plus 8 minus 1, 7. It just reduces the equation. Very efficiently it reduces. Otherwise 4 5s are, this is 60, 7 8 9. This really becomes 540. Okay, that is the answer for that. No, I have gone somewhere wrong. What is this? It has gone outside. Oh, this I did not multiply. 15 into, I multiplied 4 5 are 20, 5 60. What is there? क्या wrong हो गया? N upon 2, 15 upon 2, 2A plus N minus 1 into D. 8 has gone outside. 8 minus 1, 7. 2 stays. Oh, now this is something different. Why am I getting it wrong, or am I seeing the wrong value? Oh, my dear. Sorry, my dear students. Substitution has gone wrong, my dear students. See here, Sn means S15. Na? I'm very sorry for this again. 15 upon 2. 2 into A. A is 8. This is 15 minus 1 into D. I wrote 8 over here. This is wrong. So I get S 15 is equal to 15 upon 2 into. Now I will take common factor 8. This common factor also gone out. 2 plus 15 minus 1, 14. 15 for the 60 into 15, 14, 14, 60. So I get S 15 is equal to 6, 6, 36, 960. This is right. This I substituted wrong, my dear students. Okay, so this way we go for the 13th question, and then I think we'll finish with the 14th question. Find the sum of odd numbers between 0 to 1, between 0 to 50. So the sequence of given example is as follows: 1, 2, 3, 4, 5, 6, 7 odd numbers up to between 50, means before 50 it is going to be 49. That's all. Sum of all this. Here it is very simple, my dear students, since each term constantly increases by 2. Therefore, common difference is equal to 2 is constant. Therefore, the given sequence or example is in arithmetic progression. This we have got, where D is equal to T2 minus T1 is equal to 3 minus 1 is equal to 2. A is equal to 1, D is equal to 2, and N, we don't know what is this N, is equal to 49. Okay, so this is quite simple, because we can directly use Sn. No, we can't use Sn because we don't know N of N we will require. So here we know for arithmetic progression An is equal to A plus N minus 1 into D. Therefore An is 49 is equal to A is 1 plus, we don't know N, D is equal to 2. For An is equal to 49. 49 minus 1 is equal to N minus 1 into 2. This will be 48 divided by 2 is equal to N minus 1. 24 is equal to N minus 1. Therefore N is equal to 24 plus 1. N is equal to 25. This we have got, and now we can simply use Sn is equal to N upon 2 into A plus N. S25 is equal to 25 upon 2. A is 1. Last term is 49. So S25 is equal to 25 upon 2 into 50. 625 should be the answer of that. Is this is right. Okay, my dear students, with this we have finished up to the 14th question, and then we have got 15, 16, 17, 18. Only 4 questions. No, not 4. There are plenty more. 19, 20. Okay. 5 more questions. Okay, my dear students, with this we stop over here. But we have definitely covered considerable amount of the chapter. Okay. So go through the chapter. Of course, take care of that 11th question, which is really very, very important, very different, not of the usual slot. And get ready, my dear students. Stay home, stay safe. Most important, stay happy. See you all soon. Love you all lost. Bye, my dear.